Okay, guys, I think we're going to continue. So I think at least one of you was not here in the first part of the session. Is that true? Who wasn't here? You were not here? I think, okay, you were not here. So I explained this at the beginning. So for whatever reason, I don't know why, they decided to call the session at 8:30 session 1 and this one session 2, which sounds like there are two sessions of the same thing. They're not. They're two parts of one session. Of a 4-hour session. Now, what we just also found out is that it's really not 4 hours, it's 3.5 hours, which makes it hard to cover everything that we wanted to cover. So what we're going to do is, quick question. Who knows what are the technologies you have to know for the test? It's a very simple answer. Just one word. All. Correct. Okay. So this part that we're talking about now is about some of the technologies and their design implication. Because you have to know everything, then you have to cover everything. So I'm going to go a little bit faster and not cover everything that we had left to cover, just so that we can get to the actual test scenarios. And so Bruce is going to go cover some of the practical test questions and what they are, and we're going to discuss them, and so that and you can see what the scenarios look like and how to think about those, which is really more important than looking at this. And when you get the slides, you can look at this, and you can send us email at bep@cisco.com. That's it. That's the only email I'm going to give. No, that's fine. You can send us email. My email is very simple. It's alvaro@cisco.com. So, okay. So is that okay? Good, because you don't actually have a choice. So just remember that we got to this agreement at the very beginning that all of you who were here for the first session, you're going to give us all 5s in the evaluation. So even though I just said, you don't have a choice, well, give us all 5s. And everyone who came new for the second part, you also have to give us all 5s. True? True. Okay, great. So who can tell me what is network virtualization? Anyone? Tell me a technology associated with network virtualization. What? Didn't hear that. VNets. Sure. Anything that has V in the name, right, is a virtualization technology. Right. So the thing with virtualization is that it, of course, means many things to many people. Anything from VNets and any type of overlay, right, VM, VPC, VPLS, VRF, VDC, anything, right? But there's also other things, right, that people think about, like even HTTP. Because virtualizing, we have 2 routers, we have virtual interface, a virtual IP address, and you can choose between the 2. So there are many, many things that are considered when we talk about network virtualization. And of course, all of them can be in the test, right? So when you look at this, the same as with every other part of the technology, what you want to look at is, of course, how does it impact the design? How does it meet my ability to offer and satisfy the business and application requirements? If I'm going to do something like enterprise network virtualization, what we're talking about here is in my physical network, can I have the ability to support multiple virtual networks where I have my guest net for my wireless access, and I can shuttle them through my network so they don't get to anything too sensitive and go outside. I have whatever internal organizations that are maybe separated, sales or finance. I have firewall somewhere, things along those lines. So in general, that is the concept, right, that we're looking at. How do I separate different functions from a logical point of view in my network? So it is not just about VLANs, for example, or something that has the V in it, right? But it's about being able to separate those functions in the network fabric that I already have. And sure, many of them is going to be VPN or VPC or VRF or V of anything. Drivers, same things that we've been talking about before. Business drivers like cost. Drivers like security or availability. Drivers like simplicity in some cases. And we need to go back to what we talked about, the fact that there's trade-offs. Sure, having a full mesh of tunnels in my data center between all the hypervisors may look simpler because everyone is one hop away, right? But I still have to manage my infrastructure under it. So there is some complexity in the solution as well. So I can manage my overlay tunnels simpler than everything else, but I still have to worry about both. Now, it may be that in some organizations they have different groups to look at different things. Yeah, that's perfect. But we have to look at the implications not only of how does the virtualization make things simpler in some cases, but how it may make it complex. Just like all the other things we've been talking about before. What are the pros and what are the cons? Why are we doing this? And just like everything else, right? Tunnel is not necessarily a bad thing, but if I have to tunnel everything all the time, it may not be a good thing. Tunnels, of course, virtualize the transport, but it may mean that I don't have a direct path to the destination. Right? We talked about the case of the L3 VPN provider that has an LSP between two PEs that connect my sites, but that LSP may go who knows how until it gets to the destination. So there are implications about stretch and about performance and about reliability and other things to get to those destinations, right? MTU issues, how does it interface with routing, how does it actually scale? Can I really terminate 20,000 tunnels in my IPsec concentrator? Probably not. But so we have to think about all those implications on the design of the network. So I'm just going really fast so that we have time to cover the scenarios. So an example, simple example. Let's say we have 50 sites to interconnect. We already have MPLS. The staff actually knows what they're doing, and there's a lot of layer 2 interconnectivity requirements for, say, data center interconnect. So maybe the correct answer or the right option for this case might be VPLS, layer 2 over MPLS. It requires some certain technical ability to do that. So it fits the requirements, right? So these are again, the types of things that I want you to think about. How does it impact the design? How does it impact or satisfy the requirements that I have? So we talked about all this. We talked about pros and cons of maybe doing self-deployed a core, whether it's MPLS or not, versus having someone else control your core, right? About the control that you have, about the potential complexity, about the ability to meet or not meet the requirements. This just shows different ways of trying to load share things, where in this example what it shows is that through the backbone is the same thing, even though it looks different from the outside, right? So I may be thinking that I'm load sharing better down here, but in reality I may be ending up with the same exact behavior, right? That is because I don't control the backbone itself, right? Someone else controls the backbone. So what is the implication of that for my application? That I really have to go add that second router? Because it now makes my network more complex, but the result is the same thing, right? I still have no control over how things are load shared across my network. Different ways of deploying TE, right? Where I have things that are planned, reactive, right, to failures, for example, and similar things for, say, point-to-point different LSAs with a recovery path or different protection paths across the network. Do I really need to do this? What are the requirements that I have? How do I plan for the recovery? What are the tools that I have to do this manually, or can I do it dynamically? Different things that we need to consider when defining what that design is going to is going to look like. So TE in general, right, is a complex problem, and not just MPLS TE, but any type of traffic engineering, because that usually means that I'm going to send packets in the direction that were not meant to be sent. Right? I'm going to want to use my backup links. I'm going to want to take advantage of other things that normal routing doesn't help me with. So this can be complex, right? So obviously, if I'm looking at the design, I want to make it simple, but at the same time, I want to satisfy requirements. So are there other ways that I can do this? What is the level of complexity? And if it's going to be complex, And we know that many people do, say, MPLS TP in their networks. So when you call the TAC2 in the morning, it's easy. Hey, I have an MPLS TP network, and now we know what you're talking about. But what is the level of complexity, and what is going to be the impact? If there's actually a mistake in the definition of the LSP, so you put an LSP to the wrong destination or whatever, what is the time to recovery? What is the impact in terms of stretch, in terms of latency, in terms of the actual quality of service to actually satisfy the application? So again, I'm just going really, really fast so that we have time for the actual questions and the scenarios and everything else. Who cares about quality of service? You don't have to be shy. You can raise your hand. We won't shun you or kick you out of the room. So obviously what we want to look at here is the same things, right? Interaction with the applications. How am I going to deploy the quality of service policies so that we can satisfy those requirements and at the same time manage the interactions with the transport that I have? What happens when I get into scenarios of, class observation? What are the tools that I can put in to define those behaviors that I want to happen at different places of my network, right? So there are different meanings of what quality of service may be to the user, to different endpoints, et cetera, to the network manager, right? Where we want to, regardless of where the application is itself, we want to go manage the jitter. We want to maximize the bandwidth utilization, not only for a specific application, but for the aggregate of applications that we have on a specific link. We want to make sure that for whatever the application is, that we control jitter and packet loss, that we actually put in the right queue, the right traffic, depending on what they really need, right? Some applications need bandwidth. They don't care about delay. Some applications care about the jitter. So we want to make sure that the forwarding is handled in a way that we reduce the jitter, even if we affect other applications, but those applications may not really care about what happens, right? So we need to be really clear on what the objectives are. Do we want to protect voice at all costs? Or if I'm attacked, am I going to put emphasis on solving or mitigating an attack, for example? And that may mean getting a bunch of information of the attack vector and shunting it through a network to some other place. And if I do that, what am I affecting? Or do I do it locally? Or do I examine the information? What decisions do I want to make? So I want to be very clear about what the implications and the applications are that I'm going to go solve. So this is just technology stuff that it's nice to know, but we don't want to ask you questions about it anyways, right? Because we assume you know a lot of technology already. Some of these things, sure, we want you to maybe know some of the relationships between the different places where we can carry quality of service information and how they may be or may not be applicable. Right? The fact that your IP packet has quality of service doesn't necessarily mean that your virtualization technology has the ability to take that into account or not. Or what happens when you put this back into the tunnel? How do we do that? Other things that you of course see here is that different ones require different size packets, which is really a virtualization problem because now you have maybe MTU issues or other things that you have to care about. In general, the models are going to be things like an aggregate model, where basically there's a common QoS strategy for everything that you have in your network. Say you have a virtualized network. Or the other model is, of course, a prioritized VRF model, where now you have a different QoS strategy per VRF. And maybe you prioritize specific VRFs because you think there's more important traffic there. Obviously, doing an aggregate model is a lot simpler, right, to manage in your network because you have a common set of strategies. Now, when you're troubleshooting this, or when you're implementing this, or when you're trying to explain to someone what the network is doing, how to actually build this network, how the design is implemented, you talk in general terms, right? You don't have to go, oh, it works this way, but for this VRF or this V, whatever, it works in a different way. And for that one, I change everything upside down. And for that one, and now you put all of them in the same link, and who knows how that works, right? So you want to keep your designs simple and straight, and take into account, right, the traffic patterns, right? Is everything going into a place where I have now oversubscription, maybe? and I really care about this QoS thing? Is it going into a place like some cloud over there, which may be my L3 VPN provider, or some other virtualization where I may have a lot harder time controlling the real QoS of the network itself? Now, we do say here that we recommend the aggregate model. That doesn't mean that the aggregate model is the right question, the right answer in the exam all the time, right? We may come up with a scenario that has specific requirements for you to do something else. But just so you know that in general, that's what we think. Obviously, you have to understand what they do, how they affect jitter, delay, et cetera. How are the normal use, how do the different queuing mechanisms work. So you have to understand how QoS works before you can design it into your strategy, right? What we didn't say about that aggregate strategy is that you obviously have to have specific queuing mechanisms or specific strategies for how you're going to drop or prioritize packets. So you have to understand how, I don't know, waiter for queuing or class-based waiter for queuing works and what's the difference, so that you can then apply it and say, I'm going to do expedite forwarding here, I'm going to do whatever else, best effort on this other queue. So that you understand what that means and can now define what the aggregate QoS strategy actually means. Questions? Good. Okay. So these last two things are about network management and security, and they are very related between them. Because in both cases, what we want to do is we want to look at the network, right? We want to manage what the network is doing. And even with security, we don't only just want to protect and say, oh, I'm going to put an access list or a firewall, and that's it. Forget about security. We want to monitor, right? So we have been talking about this OODA loop. It sounds like Oompa Loompa. Who knows Oompa Loompa Chocolate Factory, right? Okay, good. This sort of model here, where it's a loop, right, where you basically it means observe, orient, decide, and act, right? In other words, just a management and security framework of things that we want to do. We want to look to see what the network is doing. We want to orient ourselves in terms of what the policies and the objectives of the network are, make decisions based on that, and then act. And then, of course, it's a loop, right? So we keep looking at it. We saw an attack, or we saw something that doesn't look good, a link that is too utilized. So what do we do? Based on objectives of the network, we make a decision and we act. And we apply a new QoS policy. Or we drop all the traffic because of a security violation, or we quarantine the user into some VLAN over there in the corner, or whatever we do. And then we keep observing, right? Because that may have an intended impact on something else. It may actually solve the problem, so we just keep monitoring for other things. So this is the general thinking when we look at management and security, right? So in here, right, the big difference is, of course, management is a little bit slower, right? Because we're just looking at stuff. Security is more critical, so we want to react a lot faster, right? So when we're observing, right, the type of things we're going to look at are things around baseline utilization or performance. So how do you know if your network is not acting normally? You need a baseline, right? If you don't know how your network acts normal, then you don't know when it's not acting normal. You have to at least know what the network looks like initially and observe things like that. You want to orient yourselves around what are the best practices, what are the business trends, what are sort of the guiding principles for your network. And so by observing and orienting yourself, now you can make decisions, right? You can make decisions, again, based on some of the best practices and other things, but on analysis that you have made on processes about change management, for example, so that you can make decisions on, okay, we're going to go shut down the link, or we're going to go change the QoS profile, or we're going to go, whatever you're going to go do. And then, of course, now we're going to act. And, from a design point of view, this may be, well, I'm going to go change the design of the network. Or I design this management system that's going to actually do something to my operating network. And some of this, as you can see here, actually, design modification, replace, inject technology, adding services. Some of these correspond to the domain tasks that we talked about at the beginning, right? We're going to measure a network. We're going to now add something, some new technology, some new service to it. So the result of your management process is not always just go change something on the fly or raise a flag in your NOC or anything like that. It may also be, oh, now I need to redesign the network because I'm seeing this long-term disruption or long-term effect of something in my network. So for security, right, we look at the same things in this loop, and I'm going to show a list of stuff. Now, one of the other things that we look at in security is different things around the network, right? We want to protect devices. We don't want, say, a DOS attack to go all the way to the servers or to the data center or other places. But we also want to protect the infrastructure itself, right? If you attack the infrastructure or if your infrastructure falls down, it's probably worse than if you attacked a specific system. And obviously protect the data itself. Not only data like from services, but data inside, routing tables, information about policies that are in the network, all these things. So there are different things we can different strategies that people take, where people make the edge of the network a lot harder than the center of the network, for example, are some cases that people use. So once you're inside, you can do more stuff, but it'll be harder to get inside of the network, for example. Other cases are, of course, the case where it's hard everywhere. So there's a crunchy everywhere. So maybe you're more paranoid, and you don't even want your users to do anything, so you added a bunch of firewalls or other stuff everywhere in the network. There are different strategies that satisfy different requirements, right? That's the whole purpose thing. So going back to that OODA loop, right? You want to do similar things, right? You want to have baselines. You want to observe what is going on. You want to decide where, how, what type of policy or reaction you're going to apply here. Now, I mentioned before quickly that the security loop is a lot faster. Well, that management loop may result in the action being, well, let's redesign the network, which means you're going to sit there for weeks and come up with plans and stuff. Where here, we may want to act a lot faster. We may want to actually have mitigation plan in place when we design the network so that we can act immediately on a threat that is happening right now. Sure, it may also result in we need to go redesign the network, but it may result in quicker actions that we want to take. Just things to look at, right? What am I actually protecting? Am I protecting the data stream, the information itself? How am I protecting that? What is the effect of virtualization, for example? Is that going to expose me more, expose me less? Now that I have to go through a provider, even if I trust them as much as whatever, what do I need to do? I need to encrypt. Is it enough that I put it in an IPsec transport? What is going to happen there? Any questions? Good. So the message is you need to know everything. So it's very simple, right? There's no complication here, no lists to memorize. Just know everything. Now, Bruce is going to walk us through the test, actual examples, so that you can ask anything you need to know. Thank you. So you're going to come or not? Oh, you want this?
I didn't think you were finished. Okay, so we're going to take a look at some sample questions from the written exam, and then we'll walk through a small scenario that's similar to what you would encounter on the exam, and we'll take a look at how you should be approaching that scenario. What are the things that you should find or should glean from the materials you get, and what do they mean? What is the intent of those things that you find in the material that you're analyzing? Is it forward? Okay. So we saw this one earlier, the silly super spirograph, crazy mesh thing, and the hub and spoke, right? So if you have this as a written question, what reason would you give that you would put an ABR at point A in the network, right? Would you do that to reduce the routing table size at router B up at the top? Would you do that to reduce the complexity of the mesh at the top? Would you put it there to reduce the impact of a failure that occurs at the router B at top from affecting router C at the bottom? Or would you put an ABR there to reduce the total SPF runtime at point A? Anybody take a guess? So how many people think it's impact the impact of B on C? Does anybody think it's not that? You do. You think it's all of the above. Okay. So it is indeed that, right? Because the fact that you do an ABR there doesn't really do anything to router B's routing table size unless you specifically do summarization. But we didn't say we were doing summarization. We just said we're going to put an ABR there. So it's not going to reduce the routing table size at all, right? Putting an ABR there does nothing to the topology of the top part. It's still as complex as it was before. You still have a full mesh of OSPF neighbors there. So it's not any less complex just because I put an ABR there. But if I do put an ABR there, now I have two separate topologies, right? And I have the changes in the topology of A don't affect the changes of topology B, or the top one and the bottom one, right? So now if there's a failure at B, that's not propagated into the hub and spoke network. So there's reduced impact on the routers in the hub and spoke network, right? What was the other one? Oh, it doesn't reduce runtime. In fact, you now have to run 2 SPFs at the ABR. So you may actually have a greater amount of SPF runtime. It kind of depends. It depends, but in general, you're going to have to run 2 SPFs now, and you're going to have to do type 3 propagation. So the ABR is actually going to have more work to do versus if it was just part of a single topology, right? So, excuse me, when you're using IPsec over GRE tunnels, how many routing instances do you need to provide reachability? Anybody? Do you need 1? Do you need 1? No. Anybody say 1? You got a 1. Okay. You say 2. Okay. Well, anybody think 3? You need 3. What do you need 3 for? Okay. Anybody think 4? 4 sounds overkill, right? Right? Well, you don't really need 3, right? Because you only need 2. You need 1 routing instance, and whether that's static routes or a dynamic routing protocol, you need 1 to provide reachability for the tunnel endpoints. And then you need a second one over the tunnel to provide reachability for the traffic that goes through the tunnel. Adding IPsec doesn't change that. It's a GRE tunnel, and regardless of whether it's encrypted or not, you need 2 routing instances to provide the reachability for the tunnel and for the traffic through the tunnel, right? So you need a routing instance to have reachability information get from one side of the tunnel to the other side of the tunnel through the tunnel, right? So let's say, for example, I run a GRE tunnel, and I'm running it from site A to site B, and I use BGP for the tunnel endpoints, right? So the tunnel endpoints know about each other through BGP over the internet, right? Now, over that GRE instance, I might run EIGRP or OSPF. And so the router at this end and the router at that end now run a dynamic routing protocol over the tunnel so that the traffic at site A, or the routes at site A are now known at site B, right? So that's where you really need to. So which would you deploy to increase the throughput of multiple TCP flows on a single link? Would you do head of queue dropping? Would you do traffic policing? Would you deploy weighted red? Or would you do traffic shaping? Someone said the third one, so weighted red. How many people think weighted red? Few. Anybody think it's not? Traffic shaping, okay. So what's the problem when you have multiple TCP flows? They synchronize, right? Right? That's the problem when you have multiple flows of the same link. You start dropping packets, that causes flows to back off. They retransmit, that causes them the same problem, and you synchronize your TCP sessions, right? Head of queue dropping isn't going to do anything. In fact, doing more dropping is probably going to cause greater synchronization, which is going to slow your throughput even more. Traffic policing, well, again, you're just dropping packets, right, and limiting throughput with policing, right? So policing doesn't really offer us any advantage there. It would just cap the throughput of something. And traffic shaping may smooth out the traffic, but it's not necessarily going to stop the synchronization of the flows, right? And so you're going to end up having the back off synchronize, right? Just like if you weren't doing traffic shaping. So really the only thing you want to do is weighted red, right? So randomly dropping packets so that different flows back off at different times, and therefore you're going to increase the throughput of any individual flow, and therefore the aggregate number of flows, okay? And of course, why do we care? Because we want to know how do applications behave and what's the relationship of an application to the layer 3 environment, right? I had a customer, I had a call from a TAC team, and they're like, can you come take a look at this customer? They deployed this new data center, and the BU's looking at the firewall. They say that the performance of their applications, their batch applications, which run at night, have gone from like 6 hours to like 15 hours. And they're pretty sure it's something to do with a crappy Cisco firewall. Well, it was actually, turns out it was a design problem. The firewall wasn't any faster or slower than the old firewall. It's that in the old data center, only 20% of the customers went through the firewall. In the new data center, 100% of the customers went through the firewall. And the application was poorly written. So some minimal increase in going through the firewall added up to aggregate poor performance. So the fact that we had more customers going through the firewall and the applications were poorly written resulted in delays, right? Nothing to do with the equipment itself. All in the fact that they didn't take into account some of these aspects when they redesigned their new data center. I hate this question, so we're going to skip it. So let's get into the practical example. As we said, the practical exam is 4 scenarios, taking into account different customer types, company types, and the different task domains that that we talked about earlier, right? That Alvaro talked about: merge, divest, adding technologies, scaling, those types of large-scale task domains. So in each given scenario, they're independent, and you're given a set of documentation about the company, about the network, about the situations at that company, and you have access to all that information during the length of that particular scenario. When you're done with that particular scenario, you move on to the next one, and you have a new set of information. The old stuff doesn't apply anymore. You get a new set of information. As you go through a scenario, you're given additional information. Remember we talked about level setting you, right? And you'll see an example of that in this practical example. So here what we have is a company called Longhorn Infrastructure Services and Provisioning. They're an ISP. It says that they provide customer support services for a range of clients. Their business model is to provide semi-customizable database environments for large companies that want to offload telephone and web support. They have a business center, a business that's centered in San Francisco. They have 2 primary locations, a data center and a corporate office located on a campus. They have 2 buildings containing a call center. On another campus, they have 2 campuses that are connected by a 10 gig Metro E. They provide services at a low cost by aggregating their product usage, call patterns, and other information on a single network infrastructure. And they sell information off as a byproduct of their operations. So when you read through this, right, you get this background, and what could you glean out of this? What do you know about them? Well, yeah, they use some Metro Ethernet. That's interesting, maybe. They have a data center and a corporate office separately. But what's really interesting here, and it's going to drive my thinking in the design, is they offer low-cost services. Well, if they offer low-cost services, they must also have low cost themselves, right? They're not in the business to lose money. So, and they use a single network infrastructure. Well, if they're using a single network infrastructure, if I'm presented with other network design challenges, adding a parallel network infrastructure may not be a good option because it's A, not going to be low cost, and B, there must be a reason why they're using a single network infrastructure, right? So at least at first glance, that's about all I get out of this, is that they provide some services and they do it at low cost, okay? Now they also, excuse me, you have, you get some other information. You find out something about their service policies, right? If you buy business from these guys, what can you expect? Well, they say we offer total privacy for all customers and client data. No data from one client is ever transferred to another client. Okay, that's nice. I like that. They want to protect my information. They have total privacy of customer and client bases. No client can ever discover what other companies are using the services unless the clients themselves give permission. The information protected to prevent disclosure of clients includes, but is not limited to, DNS and routing tables. So that means to me, if I'm using their services, nobody else will know that I'm using their services unless I tell somebody, right? They won't be able to see my routes. They won't be able to query my DNS. So it's almost like I have my own network, right? From time to time, Lisp may ask a client to provide a reference. Okay, great, that's nice, but that's not probably going to impact anything I do in the network. The network provides 5 nines of reliability, so clients can access customer databases, statistics, blah, blah, blah. No more than 1% of calls will be dropped when you call into a call center. Okay, that's nice. Network bandwidth are divided into 2 pools. They use 2 DSCP markings, bandwidth carved out of VoIP traffic based on the amount of calls, customer responsibility to mark their own traffic. Okay, that sounds reasonable. Each call center agent is fully trained and have a complete understanding. Great, okay, wonderful. Each client's web services is hosted in a highly reliant virtualized server environment. That could be interesting. The web interfaces offered customizable. Okay, great. And each client can make their the provided web server look like your own web server, and they have DNS redirection and that. So a few things that when I read this that I would glean out of this, they provide 5 nines of reliability. Well, if they're doing that, they must have redundancy, must be resilient, right? and they probably are providing some level of fast convergence or have a faster convergence policy than normal if they're getting that much reliability out of their network. Another thing is if we talked about in the first two is this privacy issue that they have. They're not sharing routes between customers. They're not sharing traffic between customers. So they have data plane and traffic plane separation, right? And it's important to provide this privacy to customers because it's part of their SLAs. So they have an SLA to their customers to provide this level of service, right? The policy for traffic to go through this network, they have some important policies. All traffic from a client connection to a server must pass through a stateful layer 3 filtering device. Traffic must be checked for viruses, conform to other common security problems, right? So it says these people who are outside the data center, customers who use these data center services when they're tunneled in, which we'll see, is they have to go through a firewall before they get into the data center, okay? Client routes can't be mixed with internal IGP routes. Clients carried in an exterior gateway protocol, which is currently BGP, and prevent clients from impacting internal network operations. So they separate their infrastructure from your routing infrastructure, right? And then traffic carried over a public network is transported in a secure tunnel to ensure private client information is not compromised. Company provides support for IPsec and SSL tunnels at customer request, but they won't allow open traffic flow between the edge of their network and a customer's network. Okay, so they're doing some kind of tunneling, secure tunneling from my location to their data center. Okay, that's good. So they have this data center network over here. So they've got the servers they provide to their customers. They got some layer 2 devices. They've got some routers, some firewalls, and then external to the network they have border routers, and then their customers connect to them through the internet. So they have a couple customers in this example, a donut shop and something called Super XL. These guys connect to their border routers where they terminate the IPsec tunnels, and then the traffic comes through the firewalls and goes to the servers. So I access these servers remotely over these IPsec tunnels. They also have a location where they have call center stations that's outside the data center but part of the network. Okay, so now I know a little bit about their network. So what's the problem now? So we know something about this company. They've given us some information. We have an understanding of some of the aspects. Well, what happens is that the donut company went and did a security audit, and they found out that they can reach servers that aren't their own servers. And they said they specifically were able to reach that customer. And they also noticed they were routes showing up in their edge devices that they didn't recognize. It was like, wait a second, what are these? These aren't our routes. So you're now tasked with, well, what's going on here? What's the problem? Do we have a network design issue here? Do we have an operational problem? What's going on, right? So the first question that you might get asked is the ability for this company, Holy Donuts, is it a problem that they can see the routes that from Super XL and they can get to the servers? And is it a problem that this company needs to address? Yes or no? Is it a problem or not? Yes? Okay. Now this leads us to a type of question we call the branching question. And whether you answer yes or no may not be the actual question I care about, right? And in fact, of course, if you answer yes, the question there's a reason why, right? And the reason why is because there's some requirements we read in their service policies that say they need to provide routing separation, they need to provide traffic separation, right? And that's what the branching questions are about. It's about if you were going to do something or if you're going to make a choice, I really don't necessarily care if you answer the right question or the question correctly or not, in some cases. In this case, it does matter. In this case, yeah, it's a problem, but what I really care about is the answer to the yes question, right? Why is it a problem, right? Or if you go down the no branch, which in this case is wrong, you may be presented a set of questions asking you why you don't think it's a problem, right? And then when you get a branching question, you really don't ever know which part of the question is being graded and whether or not it's a yes, no, or true or false, or a correct answer with justification versus a wrong answer with justification. All you know is you've been asked a series of questions. So in this case, if you went down the no branch, well, in reality, it is a problem, so you will not get points on this question because these are all distractors. These questions, the answer to the no branch doesn't matter because you went down the wrong branch in this particular type of question. So why isn't it a problem? Well, they don't think it's a problem. They can't get to the data, so it's not a breach of the SLA. They should address this by reconfiguring. I mean, these answers don't, in some cases, don't even make sense because we know it is a problem, right? But in this case, if you went down the yes branch, you first took the first step to getting the question correct. But the real question is, I want to know, why do you think it's a problem? What is it about the situation that, what are the reasoning behind, right? Is it because they shouldn't be leaking routes? Is it because they shouldn't be allowing telnet traffic to the other servers? Or are they not fulfilling their service level agreement correctly, right? Well, if you choose the first one, that's only half the answer, right? Because they're leaking traffic and routes, right? So they need traffic separation, not just routing separation, right? Same thing. If it's the telnet traffic, well, great. They're supposed to provide traffic separation, but we also have the requirement for the route separation. So the only right answer here is that they're not fulfilling the service or the service level agreements at all, period, right? And as you can see, the answer to the question is directly derived from the material that you've been given. So if you read the material and go through it, 99% of the time you should be able to figure out what the right answer is, because every question ties back to a requirement or to information that's provided to you as part of the scenario, okay? And so now I want to know, well, if there's several ways we might be able to solve this problem, which one might you choose, right? Would you maybe use PBR to separate customer traffic? Would you create a separate physical network for each customer? Would you provision a separate virtual topology for each customer? Or would you do a separate IGP instance for each customer to separate the routes, right? Well, in this case, there is a right answer, right? And the right answer is based on, again, on the requirements we've already read, right? PBR is going to do nothing about, it may do something for our routing, right? But it's not doing anything to separate the traffic, right? So we need something other than packet filters or separation of routing information. We can't do a separate physical topology because we read at the very beginning that they're low cost to single infrastructure. Well, we'd violate these business requirements if we did a separate one. Doing a separate IGP, again, doesn't separate the traffic, right? It doesn't meet both requirements. And so really the only thing we can do to provide logical separation of traffic and logical separation of a routing instance is to do some kind of a virtual topology. Now, what other information would you want to know about if you came to the decision that says, yeah, we need to do some kind of a virtual topology here? Well, there's different ways to do virtual topologies, right? I could do different types of layer 3 tunnels. I could do some layer 2 stuff. There's different ways I could do these things. So what other information would you be asking your customer or this customer in order to make a decision about what kind of virtual topology technology I would want to deploy? Would I want to know the tunneling technologies the firewalls support? Would I want to know the tunneling technologies that the call managers support? Or would I want to know the tunneling technologies used to connect to customer edge devices? Anybody? The third one? Okay. Anybody else? Third one. So the reason why this question comes up is what we talked about earlier. In real life, you sometimes need more information. You don't have what you don't have what you don't the information to make an informed decision, right? And by the way, you don't need to ask for information you already have, right? Right. So being able to discern when I have the information, when I don't, when I have conflicting information, is a very important skill that we're testing you on in the CCDE. Now, in this question, you already know what the customer tunneling technology is. We told you earlier in the requirements, right? They use either IPsec or SSL tunnels. So you already had that information. You didn't need to know what that tunneling technology is to the customers because we already told you. I don't really care what the call managers support. The call managers are over there. They're not even involved in the process of IPsec or of tunneling and security. So it makes no sense to, I don't care what they were doing. But since I know that we terminate the tunnels here right now, and if I'm going to build some kind of virtual topology for each customer here, I have to somehow provide that security and separation further than the edge of the network here, right? Because the problem is we're de-encapsulating the tunnels here and mixing the traffic and the routes, right? So if I'm going to provide a virtual topology, both traffic and routing plane, I probably, of the choices I've been given, again, the choices I was given, the only logical one that makes sense is I probably need to know something about what the firewalls are doing. Does that mean you don't need to know something about what these routers can do? No. But again, in the context of this test, you were given 3 choices, right? And this is a really important thing to get over in taking the test is, yes, in a customer scenario, there may be situations where you would choose something different than options that are given to you on the exam. Or you may say, but I'd want to know about other things before I made that decision. But this is the context of a test, and we have to guide you in certain directions, right? In order for you to be fair to you and you and you and you and you, right? So yes, you may want to know something about these routers. You may want to know something about these switches. But in the context of the test, these are the 3 choices you have at the moment, right? And it's really, and I can't emphasize enough, not reading too much into it and not saying, but I would do something different that's not listed here. That's fine. Yes, you probably will. And as somebody, I think you all said earlier, if you all went to these guys and weren't put into a box, you'd come up with 50 different answers for what the right solution is. But we bound you in certain ways in order for it to be an objective and fair test, right? I could leave this as an open-ended question and I'd get 50 different answers from each of you. And then how would I objectively grade that? I can't, right? So the only logical answer is I need to know what the firewalls support. Because we want to virtualize not just from the edge, but all the way into the network. Okay? So as we said, the firewall is in the middle. We want to extend this virtualization of these tunnels. And we probably want to, at this point, think about terminating the tunnels further in the network, and of the choices maybe on the firewalls if they can support it, right? Because if I can get the traffic to the firewalls, I have some routers here. It might support doing VRFs. They might easily support, I could do maybe .1 queues between the firewalls and the routers and .1 queues here. I may have some other options, but minimally, I think I got to get the traffic to the firewall segmented, right? Okay. So now, as I said, from time to time, you're given additional information so that you're level set. So if you said, oh, I did want to know what the tunneling protocols were at the customer edges, that's not the right answer, and you asked the wrong question, and when we originally designed the test, I said you should fail. But no, that's not the right answer. The right answer is now I need to tell you what the firewalls support. One, so that you have the information, and two, again, to guide you a little bit in a direction. By giving you that information, you realize, maybe they're wanting me to terminate tunnels on the firewalls, guiding you in a bit of a direction, right? And so I get this email. Well, actually, Amy gets it. Apparently, it came from me. I didn't know that. I said I looked through the documentation and discovered that the firewalls can switch traffic through multiple virtual instances on a single hardware platform based on MPLS or .1Q. And they can terminate IP tunnels, but they can't switch traffic out of any IP-based tunnel through multiple virtual instances. Okay, so what does that mean? It means they can terminate an MPLS tunnel, a .1Q tag. They can switch between them, but they can't take tunnel. They can't switch traffic out of IPsec tunnels between multiple instances, right? It says the servers can terminate IPsec, but it would be a major burden on their processors. The firewalls do have hardware assist blades to offload the IPsec processing, and they dump the tunnels into a .1Q on the backside. So if you're thinking, why don't they just extend the tunnels all the way to the servers? That makes sense. That would be a great solution, right? Well, no, they just told you why you can't do it, right? It's too big a burden on their processors. So, you should read that and immediately go, no way am I considering extending tunnels to the servers.
So Bruce, one point here in the previous slide. Remember the comment Alvaro was mentioning earlier. It's not always a test of best practice. So in this case, the firewall is terminating MPLS tunnel, but Cisco firewall does not. So this test does not mean that the firewall you're using is a Cisco firewall, but it's just an FYI that the network is using a firewall which is capable of terminating MPLS tunnel.
And it turns out I know one that does, actually.
Yeah.
I know one that can do MPLS.
Yeah, there could be another firewall, which is a non-Cisco device. So,
or it may not exist at all.
Yeah, but that's a customer
That's
thing.
a common argument I get from an audience is, that device you described doesn't exist in real life. How would I ever how would I find it? It exists right there. Right there, I've described to you a product that can do something. Is it a Cisco product? Is it a real product?
Doesn't matter.
Is it a made-up product? Maybe. But the fact is I've described a capability or I've described an application. I've never heard of an application that does whatever.
Yeah.
We give you that information, and you have to take it at face value that, there's something that does what they describe in the scenario.
Yeah.
Right?
And we could be challenged. If this question was on a test, you would complain, well, there was a question which was wrong. But it's not about right or wrong. It's the set of parameters that you have been given. You need to understand it, absorb it, and then respond to the question.
Exactly. So now, you're given, you've come up, or you've been talking with your colleagues and with the customer, and they've come up with 3 ideas for what we could solve this problem. Proposal 1 is, let's take the existing tunnels and extend them to the firewalls. okay? Which is kind of what I said. It seemed like it was steering us that direction, so that's one proposal. Another proposal is let's take the tunnels all the way to here and create layer 3 VPNs between the IPsec terminations and the default gateways. So here, right? Go this way. So the tunnels come all the way to here, but I separate, I use verse to separate the traffic there. Okay. The third is I extend the tunnels all the way to switches, and I do L2TP v3 between here. So I have the tunnels come in from the customers, and then I extend those tunnels using L2TP v3, layer 2, right, all the way. Okay, so those are the three proposals. And the question is, of the requirements we know, traffic separation, route separation, and relative simplicity of deployment and management, which of these solutions meet the requirements? Now, when you look at this, you go, oh gosh, there's like 9 possibilities. Does that mean I got to get it exactly right? No, think about these questions as pseudo-independent questions. So sometimes it's, I care about, will you recognize and tell me for proposal 1 which requirements will be met? And you get that part right. For proposal 2, you get that part right. And maybe proposal 3, you get it wrong. So they're semi-independent questions. Sometimes it's the row you're graded on. Sometimes it's the column you're graded on. But think of them as separate, independent questions. Because if you had to get all 9 right, most of the time, most people would get the question wrong. And some types of questions, there's even more than 9 boxes. So
this is where kind of, again, a partial scoring concept comes in.
yes, but the partial scoring.
So it's not really partial, but it's all a couple of multiple choice questions bundled into one big question. So it is, yes, it is partial scoring, but no, we see it in a different way. But from a CCIE background concept, you know that there is no partial scoring in the CCIE exam, but in CCD practical, it's different. There is an opportunity to score partially.
Yeah. So let's just take a for instance, if this was a 3-point question, and I don't know if it would be, but if this was a 3-point question, you could get 1 point for this, 1 point for this, and 1 point for that, right? Or you could so if you get 2 of them right, you get 2 out of the 3 points. So in some sense, it's 3 independent questions, or it's partial scoring of 1 question. You can look at it different ways. So proposal 1 is to extend the IPsec tunnels to the firewalls. Does that provide us traffic separation? Well, it does in some sense, because we've still got the traffic in separate tunnels here, but it doesn't really do anything for us here, right? So it's, in this case, you're going to get the answer right either way, because it kind of provides separation, but not enough separation, right? So either way, you could look at that and say, yeah, it does, but it doesn't, right? What about route separation, right? Does it provide us route separation? Well, the IPsec isn't carrying any of the routing information. The routing information is terminated at the borders, right? So you still have a route separation, right? Or you could extend the BGP over the IPsec tunnels, and you still, no matter where you move the BGP to, you could have separation over the tunnels. So yeah, you could get route separation by doing that, right? Is it relatively simple? It's probably just as easy as what I'm doing today, right? I just have to move my configuration elements from the routers to the firewalls, and firewall probably has a nice GUI to make it happen anyway, so it's probably relatively easy. And we know that it's supported by the firewall, because we got that information in that email that said, yeah, we can do that, right? Proposal 2, let's create an L3 VPN between the IPsec terminations and the default gateways. Yeah, we would get traffic separation because it's a layer 3 VPN. We get route separation. Is that really easy to do? It seems like it's a lot of complexity to me. And we know something about the company. They're low cost. We don't know how, maybe they aren't that skilled. Maybe they don't have the capability. We don't know that for sure, but in general, layer 3 VPN is people consider complex, right? But we do know the equipment can support it, right? What about extending with L2TPv3? We could get traffic separation. We could extend the BGP sessions and have separation. Is it easy to do? It adds another tunnel, right? So we're adding a second level of tunneling to this. So I would argue that it's probably not all that simplistic, right? But we also don't know. We weren't told whether it's supported by the access gateways or not, right?
Where did you get the information about that proposal? I was watching everything, and all of a sudden you said L2TPv3, and I thought, well, we've not discussed that. None of the information was discussed that. So how come that's a proposal? I got the first two from the information that's been given in the exams, but I didn't get the third one.
Right. So this was proposal 3,
Yeah.
right? You have your existing IPsec terminations here, and now take and extend that using L2TPv3 from here to here. So that's the third proposal.
From the actual information, it said about the fact that you could extend it to the servers, but you shouldn't do that.
No, they said, could we extend the IPsec tunnels to the servers? In that email, it said that extending IPsec to the servers would put extended load on them. But that's not the proposal here. The proposal here is just to simply take a layer 2 tunnel from the edge to the access switch.
Where did that come from? I didn't get it.
The email is FYI.
The email is FYI. This is the question.
This is the proposal. This will also be a document. You are
Yes.
referring to the email only.
I didn't see that. That's what I'm saying. I didn't see that.
This is
Possible solutions. Did I miss that?
No, this is what I'm saying. This is the question. The question item 4 is, here are 3 proposals. There's not a stem. There's not a good if in the exam there should be a stem that says, now you're being given 3 proposals for a solution to this problem. Here's proposal 1. Here's proposal 2. Here's proposal 3. And this example doesn't have a nice stem that says, hey, these are your proposals. Yeah. So, yeah. No. You're being told these are 3 proposals that are being considered by the customer, or you and your coworkers, or somebody, right? So now you said, okay, these are why I think they can or can't meet the requirements. I didn't ask you to select one, right? I just asked you which of the requirements could be met with these technologies, right? So this is where sometimes people get hung up and say, well, I could pick any one of those 3, right? It might do the job. But of course, we're looking for can it match the requirements? But just like if you would have chosen option 2, in real life, the customer might do something different. So now, after you've been asked which can meet the requirements, you're told the customer decided to extend their tunnels to the firewalls, right? Which you say, oh, well, that must have been what they wanted me to do. In some cases, yes, it is. In other cases, it's like, no, the customer made a stupid decision, like our customers do. And
Not you guys.
no, my customers. Only my customers do that, right? Like my customer, I was telling somebody in the break, my customer who 5 or 6 years ago, we said, under no circumstances do you outsource your corporate backbone to a layer 3 service provider. If you do, you're going to have problems. Usually going to be 5 years from now, we're going to be having a discussion about building a new backbone. Yeah, sure, like 5 years to the day. Hi, Bruce, could you come and talk to us about how to build our own layer 3 VPN backbone? Oh, okay, sure. Why did you need to do that now? Oh, well, our business entities are forcing us to do an end-to-end layer 3 VPN, and we couldn't get layer 3 VPN over our layer 3 VPN provider. We could tunnel it over GRE, but we don't want to do that. That's messy and complex, right? They made their decision, as Alvaro said, on one element, cost. They didn't think about the future that, oh, we're a multinational corporation made up of lots of business units, and the direction for most companies these days is everybody wants their own infrastructure, right? So they didn't think about the implications down the line, and there were some other things that they ran into as well. So sometimes this is the right solution, sometimes this is the wrong solution that you're given. But this is what they decided to do. And as we said, sometimes they agree with you, sometimes they don't. And if we say this is what the customer picked and we asked you to pick a solution, it doesn't necessarily mean you picked the wrong one. The customer may have picked the wrong one, and we told you that. So what routing problem remains to be solved to meet the SLA? Where we move the tunnels, so now we get the traffic separation all the way to the firewalls, but what's the remaining issue? Is it separating the traffic from the firewalls to the servers, providing routing information to the servers, or terminating the BGP sessions carried in the IPsec tunnels? Well, again, this is a branching question, right? It looks like a multiple choice question. And if you, in some cases, and this is another case where you pick the wrong branch, you get the question wrong. There are other questions where I may ask you which technology could solve this problem. There's 4 of them, and you go, this one. I go, okay, that's great. The second part of the question is going to be, why did you pick that answer? That's the more important question. You may pick any branch, and it's a valid branch to go down, but the real answer to the question is on the branch, not on the first part of the question. Well, do we need to address separating the traffic from the firewalls to the servers? Well, from the firewalls, we know that that they could do .1Q. We have switches there. So I wouldn't think that we need to separate the traffic at that point there. Do we need to give routing information to the servers? The servers never said that they were doing routing at all. So there's no basis for thinking I need to extend routing to the servers. But I do know that my routing is terminated up at the borders, but now my tunnels are terminated at the firewalls. So how are they going to know where the tunnel endpoints are? So I need to terminate the BGP session somewhere so that there's routing information for the tunnels, right? And then if I pick that one, I'm going down the correct branch, I'm going to ask you, what other piece of information do you need to know in order to terminate the BGP sessions, right? Is it the number of routes that you need to terminate? Or is it whether or not the firewalls support BGP, right? Well, I don't really need to know how many routes, probably. Customers, and I'm only terminating tunnels, probably not that germane. But if I'm going to move the peering point somewhere, I've never been told whether or not the firewalls could terminate the BGP sessions or not, right? So I think I want to know whether I can move them to there or where can I move them to, right? Once you get it, we get you some more documentation. You get some level set here. It says the firewalls definitely cannot terminate BGP sessions. They aren't designed for routing functioning except at a very minimal level. The 2 routers between the firewalls and the access switches are capable of running multiple virtual routers on a single platform and tying .1Q tunnels at layer 2 to each virtual machine. So we know that we can't terminate the BGP sessions at the firewalls. We've got to do it somewhere else. So, but what did we learn? We also learned something more than what we wanted to know. We learned that those routers can run virtual routers, and you can tie .1Qs together. That tells me how I'm going to both move my BGP session and how I'm going to do that traffic separation that I need to complete, right? Because I know I can do .1Q tunnels on the firewall. We heard that earlier. We now know we can do .1Qs and provide separate routers for separation of the control planes at those routers. So now you're asked, okay, if I'm going to move those tunnels, what is going to be the role in the network now of each of the elements here? Of each of the, right? So we have the firewalls, right? We have those routers behind the firewalls, and we have the access switches. And so you have choices for each of these. These, again, is like a set of independent questions, right? What's the role of these devices? What's the role of these devices? What's the role of these devices? And you answer them, and you can get points on each of them. So what is this? What is the firewall going to do? Is it going to be a BGP speaker, or all of these? Is it going to be? Is it going to be a BGP speaker? Is it going to be a .1Q endpoint, or is it going to do .1Q switching? And then the same for each of these. So what's the firewall's role in this? Which of the three? The firewall? What did we just learn in the last email? Can't terminate it there. So, but what we do know, if we're gonna do that traffic separation, this will be the end of a .1Q tunnel, right? Right. This guy, he's going to be the BGP speaker, but he's not going to be a he's not going to be a .1Q endpoint. He's actually going to switch packets, right? He's going to switch .1Q here through him to here. And what about the access switches? Well, they're not doing BGP. They're actually terminating the other end of the .1Q. Right? So if you got this one right and this one wrong, and this one right, you'd get partial scoring, or you'd get points for those two correct ones. Okay. So that would be the end of one scenario. Now, Yusuf, I haven't looked at version 2. I have a question. Are all 4 of the scenarios independent now, separate topologies? 2 each. Okay, so this still makes sense. I forgot to ask that. So now you're done with that problem. You've solved the issue of separating their traffic and separating the routing, and you're done with that scenario. All done. Okay? Now it's time to move on to a new scenario. Same company, same topology, but they may have a different, you're giving it in a different task domain. You're doing something different, right? So this is the new scenario, right? It's the same company, but now what they're saying is we have the folks out in that call center, they're rolling out an application and want to know what do they need to do to the network to support it. It's a video app they're going to use for training for folks who come to the call center, to bring them up to speed on what products we are providing support for. Okay, great. Sounds cool. So we're adding video to the network. That's about all I get out of this, right? What do you need to know? Based on what you already know about the network, what you've seen so far, what information do you need in order to suggest changes, or if any changes are needed at all in this network? Do you need to know what the average length of the videos are going to be? Do you need to know whether it's interactive or streaming? Do you need to know what codecs they're using? Or do you need to know what the desktop application is that they're using? Anybody? Interactive streaming, yeah. It's a pretty obvious one, right? But it's meant to be illustrative, right? We don't care how long they are. We don't care what they're using. We don't care how they're encoded. We really care about, do I have to do interactive, or can I just stream it, right? Level set you. I called the vendor, and I talked to the business managers. The application is a streaming on-demand system to provide training to the agents or agents who are picking up. There are 2 servers sized to feed 5 or 6 streams. If a new stream is attempted beyond what the server supports, they get an error. So it has some rate limiting or some admission control. To get around this limitation, they're planning on using a scheduling system so folks watch them in groups. They're expecting pilot runs for 10 to 20 people will be, based on their pilot runs, they're expecting 10 to 20 people will watch a video at any given time. So basically what they said is they can do it on demand, but they're going to use a scheduling system to do that, and they only really support 5 or 6 feeds in total, so they're going to watch in groups. Okay, that's good. Tells me something about how they anticipate using the product. So how does my network need to react to that, right? Now that you've got that information, what other things do you want to know in order to make an evaluation of the network changes? Do you need to know what the utilization of the data center to call center links are? Do you need to know the average delay between the data center and the call center? Do you need to know the quality of service configurations? Or do you need to know the average jitter level? Delay? Utilization? Why would delay be delay be important in a streaming application? No, right? Fine, so there's a delay. It takes time for it to start up. Packets arrive in sequence. Okay, so it's a little delayed, right? So that's why you can watch broadcast TV over satellite, right? It's streamed. Don't care how long it takes. It comes to you. So the event was, the event going on was 4 seconds ago. Okay, great. You get the video 4 seconds later. Great, right? So I don't really care about the delay. I don't care about, it's a streaming, I don't care about, it's why did we say that? Yeah. So I really care about is do we have any quality of service existing that would protect this traffic from other traffic, right? That's really what we need to know. So now someone said, "Hey, is this a good? This video we're rolling out? Is that a good application for multicast? Is it? Yeah. Okay. Well, if you went down the no path, you're right. This is a good application for multicast, right? Single streams, right? In this case, the yes branch doesn't have any follow-up questions. That you recognize that it's good for multicast, that's enough in this question. What routing protocol would you recommend for this? Would you recommend multicast OSPF, PIM sparse, PIM dense, or PIM biter? Well, I don't think anybody ever rolled out multicast OSPF, have they? And we all know you never use dense, ever, right? I think we've said that forever. So your choice is between sparse and biter. When would you use sparse versus biter? Well, we don't have any requirement for biter. We don't have many-to-manys, right? Really? We have speaker to receivers. So sparse is really is probably the most simplistic thing. You could you deploy biter? Sure, but it's overkill, right? So let's do sparse. Okay. So that's an overview of two scenarios. It shows you a couple different things. It shows you how to approach the information you get, the fact that you get additional information that helps level set you as you go through the exam. It shows you different types of questions that you're going to encounter. The branching questions, some check boxes, there may be some drag and drops as well. Do we still have actual drawing questions where you're given a palette with a limited set of devices and you're said, where would you add a router, or where would you, right? So you may be given small design drag and drops, put a router, where would you put a router, where would you put a firewall, or links, or, right. So kind of give you an idea of different question types that you'll encounter and a little bit of the flow of what the exam looks like. Okay? Any questions?
All these four scenarios given at the start of the exam, or will be given sequentially?
Say that again?
Four scenarios will be given at the start of the exam, or
in sequence. So you do the first one, You say, I'm done. You go on to the next one. I'm done. You take lunch. You come back. You get the third one. I'm done. And the fourth one, I'm done. You can't go back. Each one's limited to 2 hours. And you can see why you can't go back in items, right? Because if I level set you, you would go back and change your answer, right? So, other questions? If you finish early, can you move on to another one? Yeah, absolutely. If you get done with one in an hour, you move on. No, you can't. That's the only limitation. You can, if you finish one early and you go on to 2, you have to wait till after lunch for third and fourth. So the question is, how often is the blueprint changing? Did we update it for version 2, or was it? Or we just clarify?
We updated the blue. So there is no algorithm or logic that every 2 years we'll change it or every 3 years. It's on demand. It depends on the technology evolution or on the advancements of the program. The last time we changed was in February 2010 or 11, something like that.
12, I thought.
12, yeah. I think, Teresa moved in 12, yeah.
Yeah.
So we recently changed. It's only like been 2 years or so. So, it's on the roadmap. It's on the radar. We may change it, but we don't have it right now laid out. And if we do, the good news is we'll give you sufficient heads up time to kind of do the transition. So we'll give notice that, CCD program is changing. This is the cutover 6 months from now. So you want to do the old one or the new one. Like we said earlier, it's an infrastructure exam. It's a layer 3 focus exam.
So is there data center technology to the extent that there's layer 2, and to the extent that we may talk about applications that you would find in the data center? Sure. But is it, how do I design a storage network, or how do I design the converged fiber channel UCS network? No, there's not that level of detail. I don't think there are any topics on wireless. Much like CCIE, it's like wireless is really its kind of own entity, to the extent that IP is IP over relatively over any media. It may come up as, the customer has some wireless, or they use 4G for certain things, and you have to take into account what that might mean in the scenario. But it's not like, let's go design a wireless infrastructure, putting controllers and antennas and that. No, not that.
And same thing for voice and video. I mean, there will be references to those technologies, but you won't require to design voice or wireless.
I'm not going to ask you about doing a dial plan.
The provisioning of it.
But take into account, let's say that you have a scenario and they're talking about there's voice traffic, and they say they haven't designed a call admission control system. Oh, well, that's interesting information, right? Or they say, they have designed a call admission control policy. For this size site, they allow 5 traffics, and they're 5 phone calls at a time using whatever codec is, right? And you can go, okay, that means something to me. I've got a cap that I can identify based on that. So voice design in that sense, and how it interacts with layer 3 and our QoS policies and security and all that stuff, absolutely is applicable. But design the dial plan?
It's again the impact.
Yeah, the impact, right? Or if they tell you, they say they have centralized call managers. Oh, And they didn't spend the money to get Call Manager Express. Well, that might mean something to my resiliency requirements, right? Because they need to be able to get to their call managers, right? So again, how voice and how applications and such, where they live, where services live and such, definitely affects our design decisions, right? But we're not designing the voice infrastructure itself, right? That make sense?
Oh, that's a good question. So the exam is a window-based exam. So it's delivered once a quarter. So we publish dates in advance. So if you go to our website on Cisco Learning Network, you will see the schedule for 2014. And I think we've also published for 2015. So the dates are there. The location is at Pearson Professional Center, what we call PPC. So it's not the regular Pearson Center where you go to do the written exam. These are special centers, high stake, high security, Pearson professional centers, and you can search for the nearest in your location. I think in Australia there is one in Sydney.
And Melbourne.
And Melbourne, yeah. So you can book wherever in the world there is a PPC, you can book your exam over there globally. But at a specific date, which we have published. Yeah, you don't need a technical proctor to do a CCD exam.
And the Pearson Professional Centers, as Yusuf said, are not the contract Pearson View Centers. They're owned by Pearson, and they deliver high-stakes exams. They're like nursing exams, stockbroker,
medical board,
other stuff, other legal things, right? So it's like when you walk in, you have to like empty all your pockets out and put all your stuff away, and they have video camera on top of you the whole time, and their proctors are trained to look for how people cheat and that kind of stuff. So it's very, very different experience than if you go to the regular Pearson centers or Pearson View centers for doing your written exams. Question is it open book? No. There is no access to any documentation. No, I had someone ask me or suggest that we ought to provide some generalized descriptions of some of the technologies that we include on the exam for those who know about it but may not know it in depth. And I said I would bring that suggestion back and see if that was something that would be considered. But there is no access to Cisco documentation, to the internet, or anything like that. So.
But see, again, going back to your point, I mean, this exam is not your knowledge that you bring in from your best practice or from books and all that. You have to follow the scenario. All, like I think Bruce or Alvaro mentioned, 99% of the answers are embedded in the scenario. You just need to look for it.
Right, and well, with any of our exams, we make decisions about what things we want to test in the written versus what we want to test in the practical. So, for example, in CCIE Route Switch 5, PFR is still on the exam, much to the contrary of what other people have said. We've moved it. There is no practical lab configuration, but there are questions on the written about PFR. So there may be technologies that we chose to ask you about to see if you understand them and their implications and how they work that we choose to ask you on the written exam, and we don't want to do it on the practical, right? Or it doesn't fit into what we're trying to do in the practical, the skills we're trying to assess. Because if you go and read the blueprints, right, the written exam is about how do technologies work and why do they work that way, right? That's to get an understanding of your understanding of technology. The skills on the blueprint are the applications of those technologies, and the skills that we're testing or we're evaluating are how you are not that you know the technologies, but can you use them and can you do it